Okay, in this presentation we're going to look at the gamma distribution. So x is a random variable having a gamma distribution with a mean alpha times lambda and a variance of alpha times lambda squared. This is important actually. This is a big clue as to what we do later on. This is sort of represents a key landmark or key branching of the road, and let the ith cumulant of the distribution of x be denoted kappa I. So essentially what we're going to be working with is moment generating functions and the cumulant generating function of x. And what we're going to do is calculate kappa 2, kappa 3 and kappa 4, which are cumulants. So the first thing we have to do is decide what is the moment generating function. Okay, so there's two ways of specifying the gamma distribution. One is using the shape parameter and the scale parameter, okay, and the other one is using the shape parameter and the rate parameter. Now, usually I sort of separate these out with different notation just for added clarity. But in this case, what I'm going to do is actually make it as unclear as possible. And what we have to do is figure out what we should be doing here. So the expected value of x using the type 1 distribution is alpha times lambda. In this case, it is the second case, the type 2 distribution using the shape and the rate parameter. That will be alpha over lambda. Okay, so clearly what we're dealing with here is a type 1 specification. So this is lambda here is actually the scale parameter. Okay, now that's a big decision. Okay, that's a sort of banana skin, and it's sort of intentionally put there to trip you up. Okay, so if it was alpha over lambda, you know it was the other one. Okay, anyway, so this is the moment generating function, 1 minus lambda t to the power of minus alpha for t less than 1 over lambda. Okay, so we're going to take a very straightforward approach to this here. Okay, so x has a gamma distribution with mean lambda, alpha times lambda, and variance alpha lambda squared. Okay, so essentially this is what I got here. Okay, you can disregard that. I sort of explained that. It's the type 1 distribution, type 1 specification. Now, that's the moment generating function of x for this case here. But what we need is the cumulant generating function, the CGF, okay? And it's the natural log of that expression there. So it's the natural log of 1 minus t lambda to the power of minus alpha. Okay. Now, so essentially what we can do here is we can use series expansions. Okay. These are the building blocks of mathematics. Okay. So do expect all these sort of fundamental parts of mathematics to crop up in a lot of these calculations, particularly with cumulative generating functions and so on. Just, always be mindful that these things might pop up on your radar unexpectedly. So just be careful about that. Now, so essentially what we have here is, first off, I'm just going to go back here a second, and we're just going to re-express this as, so essentially what we have here is the log to the base e of 1 minus t lambda minus alpha. So what I'm going to do here is just re-express that as minus alpha times log to the base e of 1 minus t lambda. Okay, and this is what we're going to use the series expansion for, that part there. And really it's a straightforward enough job. Okay, so I just actually put that both into shot there. Oops, didn't mean to do that. There we go. So there we have it there. Okay, so essentially what we're going to use that expression there, minus x squared over 2 minus x cubed over 3. But in this case what we're going to use instead of x is t times lambda. Okay, so yeah, that's actually sort of explaining how I got it. So that's just the explaining my progression there. Okay, so yeah, actually that's it. So that's the steps there. I've just sort of got through it there. So that's the minus alpha there, and again that's using the using the laws of logarithms just to bring that outside, just to sort of simplify things. Okay, and that's just using the expansion there, just above. So we have minus t lambda minus t lambda squared over 2 minus t lambda cubed over 3, and so on. Okay, and when I just multiply the whole thing by alpha or minus alpha, I get minus alpha times t minus alpha squared over 2 times t squared, and so on. Okay, now I deliberately isolated out the t terms here just to make things a little bit easier. Okay, well, actually, you know what? That's how you would probably express the cumulative generating function there. Okay, but we got one more step to go. Okay, now this is the definition of the cumulative or the cumulants, and how would they relate to the cumulative generation function. Essentially, it's the coefficients of the cumulative generation function for this expansion here. Okay, now that's n factorial there. Okay, so what I want to do here is re-express everything in consecutive powers or ascending powers of t over that power. Oh, sorry, that's the first one here. So t to the power of 1 over 1 factorial alpha lambda. And in the next case, what we want is t squared over 2. So essentially 2 factorial, which is 2. And we just re-express what's left. We reconcile it. And we have alpha times lambda squared. Okay. And the next case, what I want is an expression in terms of t cubed over 3 factorial. Okay. So which is over 6. So essentially what I have to do is re-multiply the numerator by 2 so that it reconciles back to, so if you cancel it down, you get alpha times lambda squared over 3. So essentially I'm doing a simplification in reverse is what I'm doing. Okay, an expansion, if you will. Okay, now the reason is I want it in terms of I want everything in terms of t to the power of I over I factorial. Oops, yeah, I factorial. It's a bit weird looking at it, but that's correct. Okay, so I want the coefficient in each case, and these are those coefficients there. Okay, and the fourth one will be 6 alpha lambda to the power of 4. Okay, yeah. What's that there? That's just a typo. Yeah. So, yeah, so essentially if I was to simplify this expression here, that's what I get. That's the gist of it there. Okay. Now, that's good. So essentially that's really brings us to the home straight here. Those are the kappas that we're looking for. Now, we weren't asked for kappa 1 because it's straightforward enough. Okay. But those are our kappas. Kappa 1, kappa 2, kappa 3, kappa 4. So they are starting with the one we were asked for, kappa 2. That's alpha times lambda squared. Kappa 3 is 2 alpha times lambda cubed. And kappa 4 is 6 alpha times lambda to the power of 4. If you want a general expression there, I have a few notes there, but that's actually, I'm just going to sort of highlight that as the general expression there, the general term. Okay, I think I'm missing a factorial there. Yes, I am. Okay. It's messing around with my factorials, so I won't worry about that too much. Anyway, so that's it there. Okay, so it's I minus 1 factorial times alpha lambda to the power of I. Okay. Right, I think that's it. We'll leave that there. That's the cumulant generating function for the gamma distribution.